Alrighty, good afternoon, everybody. Welcome to session one of our CyberHawks Cyber Defense Bootcamp. Today we'll be going over computer networking, and we're going to do that in three machines. And what we're really kind of trying to learn there is that, again, with certain Linux distributions, there are going to be some slight differences the way that they handle certain things. And so the CentOS is going to set up their networking infrastructure one way, Ubuntu is going to use some other utility, and then Debian is going to use another one. So that's what we'll be taking a look at today. I'll start with a general primer on just what networking is in general. We'll talk about specifically IP subnetting. So if you ever see something like a /24, that is what's known as a CIDR address, and it's related to subnetting. And it's a way in which we can kind of increase the number of computers that we can have out in the wild without fully exhausting the range of IPv4. So that'll be something that we'll take a look at as one of the first two things that we do today. Before I begin, I did have a few announcements. So first of all is I managed to get through and I set up all the users for our Block B students. And so you now have access to the learning environment as well. There are some slight changes between Block A and Block B, and I apologize for that. Rather than directly copying the machines over, which would take a very long time, it was quicker for me just to create a new fresh image on those machines and then use a template for that. And so there are some slight differences. One of them is that the username and password on the two Kali machines is slightly different. I don't know. I don't remember exactly why that might be. So for instance, on the Block A students, Kali and Kali is the username and password that you can use. But our Block B students, it is going to be root and then Tor. So if I go ahead and put that in there. So for instance, here is our external Kali machine. The username for that one is going to be root, and then the password is going to be Tor. So just root backwards. So if I go ahead and use that, it'll go ahead and log me in. So it should, we're not going to be using too many tools on Kali Linux as part of the seminar series. So there's not too many other major differences between the two. You'll see that at least with the command line here, it's slightly different. And if you want to change it so that it's in line with what Block A has, you can use the password command. So you can say password Kali. Let's see, I ran this. I don't know why it didn't accept it. And then I'll just add in the new password. So in this case, the password has been updated. I guess I'll show that again real quick because I exited it out really quickly. Password Kali, and then it'll ask for the new password, and then I'll retype it just to make sure. And so then it's updated successfully. I can go ahead and I can log out at that point. Give it a second to go back. And then I can use Kali and Kali. And so that's just as a note there. I apologize again for when I was putting everything together. And this looks exactly like how the terminal or the screen is going to look like for the Block A students. So I just wanted to make that announcement there. As a quick refresher in terms of how do we access the environment, let me go ahead and show that real quick. You're going to head out to, for our Block A students, it's going to end in 123, and our Block B students, it'll end in 122. So if I go ahead and head out there, and again, I guess one thing to note is that technically you'll still be able to access it if you use either the Block A or the Block B IP address. It's just technically there's a slightly better performance if you're using the web interface from the one that your machines are assigned to. So practically speaking, there really isn't much of a difference, but in theory, there would be. You'll be met with the private. Unfortunately, again, we are using self-signed certificates with this, so we don't really have a workaround for that. And you'll go ahead and sign in. So I'm going to use this user today. I'll have to switch over to the other one. You'll use it. We don't have a subscription on this at the moment, so you're just going to go ahead and hit OK, and then you'll see your machines here. Today we're going to be using 4 of the machines. So we're going to be using the Cent router. So we'll go ahead and get that started, and then we'll do some of the theory and the terminology. We'll discuss some of that. So while we're doing that, we'll let the machine spin up. So we'll be using the Cent router. We'll be using the Cent web, the Ubuntu work, and the Debian DNS. So if you're following along at home, or if you're doing it here with us over Zoom, go ahead and start those 4 servers up, and we'll be using those today. And I'll talk a little bit about kind of what the goal is, why we've used this this infrastructure, the way we've set it up this way. But at least those ones are the ones that you're going to be using. I think on Thursday or Wednesday next week, we'll be starting to do more stuff with the Kali Linux machines, but you can just leave those off for the moment. And let me just double check. Yeah, so you can just leave those off for the moment. So that's just as a quick note there for your knowledge. All righty, cool. So we'll go ahead and get into it. I have a few quick slides just kind of going over some of the other stuff. So again, on Monday, or Monday, we talked over some command line stuff. So if you're completely unfamiliar with the command line, go ahead and head back to that and watch through that. It'll give you some good places to start for some commands that you might want to investigate and look into. I also talked a little bit about the over-the-wire bandit challenges that you can go ahead and do. Those are over SSH. It's on their own platform, but it's a really great way to get a little bit more familiar with how do you move around the command line. And that's kind of one of the things with a lot of topics in cybersecurity, at least what I found, is that a lot of the time it really just takes kind of working with it. And sometimes there's a lot of referring back and forth. So maybe you've got notes or you've got like a cheat sheet that you may have put together. And a lot of the times you're just kind of going back and forth. At the beginning, you're going back and forth. You're like, oh gosh, I don't remember how to do this specific thing. And over time, it'll kind of become second nature. So if you're struggling a little bit with command line, know that it just kind of keep working with it and keep working with it. And at a certain point, you'll kind of have that aha moment. And it'll just kind of be second nature to you. You'll be able to go as fast as maybe myself or some of the other CyberHawks exec board members are working with things. So that's just kind of my tip to you if you're brand new to cybersecurity or just networking in general. Today we'll be doing some stuff with computer networking. So we'll be setting up a very basic network infrastructure. Not going to go too special with it, but it fits within a few different competition environments. So specifically, if you're interested in competing as part of our NCAE cyber games, at the very least on their regional level, they use a very similar network topology for something like that. So that's kind of what we're aiming for that, but it also applies somewhat to other competition. So for instance, the collegiate cyber defense competition as well. It would be a good analog to that as well. On Thursday, we'll do some ports and services stuff. So we'll learn how to install a few things using the different installation package managers that are on each of these machines here. And then next week, we'll go into some red teaming and firewalling. So some fun stuff coming up here. Again, just to kind of a recap with kind of the sessions, we'll go for about an hour. We'll take about a break. I don't know. We'll see. I've allocated about 30 minutes to question and answer, but kind of depending if there aren't any questions, we'll just take a shorter break here and jump right back into it. And then we'll kind of keep going from there. Alrighty. So at least in terms of general networking, I wanted to kind of give just an overview of kind of what we're working with here. It'll heavily focus on just kind of IP addressing and subnetting, because that's one of the things that we work with on a pretty usual basis within these environments. So at least in terms of kind of different ways that computers identify each other. So the first two that we have are your MAC addresses and your IP addresses. The MAC address is a physical address that's tied to the machine. So each machine, you're even a lot of times like cell phones and things like that, they will have one too. At least in terms of working within an IP infrastructure you're dealing with wireless. So that's the physical address tied to the machine. I don't remember how many are in the range for how many bits that they have assigned to it. But generally speaking, it's one where, let's see, it's a large enough range where at least within a local network, you don't really have to worry about anything doubling up. The second one is going to be your IP addresses, and it's a network address of the machine. And so it's a way in which computers can then communicate with each other within the network. And then if you have a more global IP address or a public IP address, you can then communicate with other machines around the world. It's also important to note that both can be spoofed. There's different ways that you can do this. On Windows, you can actually use it within the device manager. You can go ahead and find your Ethernet interface card, and you can go ahead and change it directly on there. And then typically you have to then do a system restart in order for that to get applied. But you can just change your MAC address directly on there. Your IP address can also be spoofed. So know that all of these can be kind of modified in a certain way. We tie these together what's known as ARP, or Address Resolution Protocol. We're not going to go too much into that, but there are some cyber attacks that you can kind of launch against that. You can kind of overwhelm the network with a large number of those requests or identifiers between the MAC and the IP address. With the MAC address, again, it's written in 6 pairs, so there's 12 bytes total, and then there's the address resolution protocol. We're really not going to touch on this too much. When we're working with the CentOS machines, that one can be a little bit finicky with the configuration files. You can specify what the MAC address of the machine is, but you don't necessarily have to. But if you give it the wrong one when you're talking about a specific interface, it'll get mad at you. So that's just as a note there. And then we have the IP addresses. So with IP, we use IPv4 and then IPv6 is the newer one. IPv4, you'll see it kind of here. When we're accessing the server environment, we're using an IPv4 address in order to address it. So we have 4 different sets of numbers here. We have this first one here, and they're all separated by dots. We use decimal notation when just talking about the general number, but there are a total of 32 bits that make up the full string there. And the total address space is, let's see if I can get the number right. I think it looks like it's 4,290,000 addresses. And you may think that that's a lot, but when we consider how many people there are on Earth and how many devices each of us had, we've long past exhausted that total address range. So when we're talking about subnetting, that's somewhat of a solution that we found for that. But another solution is we could move over to IPv6, which provides us with an even longer range of addresses that we can use. And that one uses hexadecimal. It's a really funky one. So if you look at it here, you see these 2 colons. That's what's used to, well, I forget which one is it to separate, but it cuts off based if there's a whole bunch of zeros in a row, it cuts it off with I believe the double colons. So it can be a little bit tricky to kind of visually read that and visually remember them. It's not as easy as IPv4, but it increases the address range dramatically. So in this case, there's 128 bits or around 16 bytes with a total of 3.4 e to the 38. So who knows? I mean, that's a really large number. But unfortunately, because IPv4 is the legacy one, it's the one that we've used for a long time. Any legacy devices are not necessarily going to be able to easily transition over to IPv6, depending on how they were built. And so we've really been stuck in IPv4 for an exceptionally long time. So that's just something to kind of make you think about kind of where things are headed with this. But right now it's still a mix. There are some attacks that can happen. So there's different ways in which different attacks can go through where you set up the IPv4 and then you forget to disable IPv6 or something like that, and someone's able to then claim that IPv6 in your network. So there's different kinds of attacks. So just be aware that IPv6 exists, and that you should have some knowledge of them at some level. In terms of assignment, there are 2 different ways, generally speaking, that we assign those IP addresses. You could use static IP addresses. So we can manually set what the IP address that we want to work with here. And that's what we'll do today. So we'll go into the machines, we'll go into our 4 machines, and we'll set our IP addresses there. But we can also use the dynamic host configuration protocol. It is an automated system. And basically what it'll do is it'll wait for, I think it either waits for requests or it's just kind of sending, hey, does anybody need an IP address? I'll have to double check on the specific protocol. The CentOS machine, the Cent router, will already have one of its interfaces that will be using DHCP to get its IP address. So it's already set and it's ready to go there. There are a few address spaces that we have to be kind of aware about that we can't use. So for instance, there's the loopback address. So it's 127. Most things that start with 127. That's generally speaking going to be talking about yourself. But there are certain private address range, and this is concerned with if I'm creating a public IP address. So in this case, the 10.0 range all the way to 10.255 range, 172.16 to 172.31, and then 192.168 to it looks like to 255.255. So we'll actually be doing stuff with the 192 to 168 range today because we are using this in a private network. We're allowed to use that. But if you try to shoot out something to something on the wider internet, you won't be able to find anything on those IP ranges. Then we also have some invalid addresses. So anything that starts with 127 or all zeros or all ones. So that's just as a note there. In order to address that address exhaustion, what they ended up creating was subnetting or network address translation. And so if we take two sets of networks, so if I take it here, if I go ahead and draw on my screen here. So let's say that we wanted to, let's see. So let's say that this is the wider internet, and then this is my internal network. So let me use a different color here. And then let's say that this is my internal network, and I'll add some text here real quick. So this is internal, and then this is this one up here. Oh, and then this one up here is the wider internet. What they ended up thinking about was, hey, well, we don't need to give everybody a public IP address because generally speaking, if we have a set of servers that live in here, so like we have one server, two servers, three servers, who knows how many servers we have in here. Not all of those necessarily need to be public facing. They don't all need to go out and reach out to the internet. And you also see this too with like if you have a wireless access point, like when you're at home, and you have your own local IP address there within your own network. And then your router will be the one that is forwarding and getting all the information out to the internet. So what they said was, well, if I have a whole bunch of internal sets, I could reuse some of these IP addresses within here. And just at the local level, they'll use those IP addresses. And then that saves up a lot of space when we're looking at the wider internet. And the way that works is you'll have like the gateway or the router, and it'll basically handle requests on behalf of the folks on the inside. And that's where network address translation comes into play. And as part of that, in order to help with that, what they ended up using is they created this subnetting. And they have what's known as a subnet mask, which indicates what belongs to quote unquote the network and what belongs to the device. It's written as a set of 4 bytes, and each one represents what belongs to the network and what belongs to the devices. So, and we'll see this as we do some of the math, it'll kind of be a little bit clearer on exactly what that means. But we also have CIDR notation, which is a more compact notation, a more compact representation of what that IP address is. So for example, we have this 10.10.10.10/24. And the /24 just tells us how many ones there are. So there's going to be 21 ones in this address here. It'll turn into 255.255.255.0. So that's just the very basics of that subnetting. There are a few different classes. I don't remember if there's technically a class B, a class D. And actually, I'll have to double check on this. So I'll have to double check on this. I feel like there's an additional class D. So we'll come back to this. I'm just going to skip this because I'm not entirely positive on this one. So we'll come back to that. But just know that based on the subnet mask, there are different classes that are associated with the leading. So in this case, anything that 255 and then the 3 remaining zeros, then 2 255s, then 2 zeros, and then 3 255s, and then 0. So I don't remember specifically, so don't quote me on this one. I'll have to double check. But at least in terms of what the math means is that the 0-bit indicates a host that's available. So for instance, if I have that example there, so 10.10.10.10/24, that equates to a submask of 255.255.255.0. And the way that works is, what that's telling me is that these first 10 bits, these first 10, or they're not these first 10, these first 3 numbers, that's going to be associated with, say, the router. And then everything that is that 0 here, so about 254, we'll explain why it's 254, can be used by devices on the net. So here we go. So the subnet mask for the entire internet So let's say that we've allowed all IP addresses. We're just directly using the direct internet. Every device, we're not even using any network. We're not using any NAT. That could be all zeros for that. Another one could be this 255, 255, 255, which is this 24 address. So there's 8 bits in each decibel number that we're using here. So there's going to be 8 ones and then 8 zeros. And here we have another sample here. So with 22, there's going to be 22 ones. And then you can use a so if you have like a Windows machine, you can use the calculator. You can switch on over. There is a programming calculator, and you can quickly find out. So for instance, if you need to figure out real quick, okay, there's 8 ones here. I can go into binary, and I give it 8 ones, and it tells me that that number is 255. So that's just how I would go about that. I do highly recommend learning binary. That would be a good skill to have. We won't cover it here, but that would be one thing that you should look into. But at least for something like this, you can quickly use this little calculator for doing some stuff. At least in terms of the number of hosts, I'll discuss the math in terms of figuring that out in a minute. So here I have hosts is 1,024, but realistically we can only use 1,022. We'll go ahead and clear that slide. All righty. So here we go. If I want to figure out the network ID, so as I mentioned here, we have this is the IP address. So here we have this is IP, and then this is the subnet. We want to figure out with this what I said, where this determines how much belongs to the network and how much belongs to the devices. What you'll end up doing is you'll convert the IP address to binary. So in this case, we have decibel. Oops. So in this case, we have 192, and 192 in binary is 1100, 1100, and then 4 zeros. So we go ahead and add that here. 168 is 1010, and then 1 and then 3 zeros. And then we have two sets of 0. So 16 more zeros. And then we've already seen 255. 255 is 81. So we have 41, 41, and we keep going. And all you have to do is you do the AND operation. And so in binary, when you do the AND operation, and I believe you can do this in this calculator here, essentially, if you have both of these have to be a 1 to drop down, essentially. So 1 and 1 becomes 1, 1 and 1 becomes 1, 0 and 1 becomes 0. So most of the time, what you'll end up seeing is like if you see a 255, you know that the number that corresponds to that and the IP address is just staying there. So in this case, we see the network ID is 192.168.0.0. So that would be how you'd figure that out. And then in a minute, we'll look at how many devices can fit within that range there. So we'll clear this out. So in order to figure out the number of hosts, the way I do it, I'm sure there's other ways that are equally as good. But at least the way I do it is I take the inverse of the mask. So I flip it. And the way you can think of this is if I figured out if this number is related to the network, and then the remaining space here is the number of devices that I have, I can just flip the value or flip the mask. So in this case, rather than a 0 here, it becomes 255. So 255. And then you have to consider that it's in binary. Even though we flipped it, there's still technically one more that we can use here. So we have 256 hosts. So if I see here, we already saw that 255. 255, and then I just added 1 to it, and it became 256. We can do that with the second one here. There's 8 ones, so there's 16 ones here because we have a smaller mask. So in this case, if I go here, 1, 2, 3, 4, 4, we have 65,535. I add 1, and then we get 65,536. In addition to that, we also have to consider that we have the network ID in there, and then there's what's known as the broadcast. So in this case, technically speaking, we have to subtract 2. we have to subtract one for the gateway, and then the broadcast address. The broadcast is just a way in which we can just message everybody within that internal network. And here we go. Here's another one. And with this one, I add the network ID with the inverse of the subnet map. It's just going to be the maximum value on the range. So if I consider an IP address of 192.168.0.0 and a mask of this, the highest number here on the very end is going to be 255. And so naturally, the broadcast is going to be 168.0.255. That would just be kind of how that one functions from that point of view. But we can do this math. We can do this with the same math idea. So we'll take the network ID and then we'll just add it to the inverse of the mask. So we end up with the value that we saw before, and then we saw it here. So that's just a general overview of those subnettings. I wanted to kind of give this overview. I know I kind of ran through it really quickly, so I do apologize for that. But I just kind of wanted to give a general overview. We're going to see a little bit in terms of that subnet mask with the CentOS router. So I just kind of wanted to make you aware of kind of why that exists and how that plays into how that network addressing works. So at the very least, in terms of how this relates to the network environment. So within each of our networks, we have 6 total machines. We have 2 Kali machines. We have an external Kali machine and an internal Kali machine. The reason that we did this was we wanted some way to show you what the potential weaknesses could be if someone were to compromise a device within your network. So maybe you have a network-based firewall, or you have something that's filtering traffic between reaching the internal network with the exterior network. But in theory, someone could breach that and they could hack and they could gain access to something within the internal network. So we wanted to show you what the attack surfaces look like from those 2 point of views. So that's why we have these two Kali machines here. We have 2 Cent machines. We picked CentOS for this one because we find it easier to set up a router with CentOS than some of the other distributions. It is possible, but we find it easier on the CentOS, and we'll see that today and some of the reason as to why. But we have one that's going to act as a router. So all his job is going to be is to transfer traffic between the external zone and the internal zone. When we talk about firewalls next week, we'll talk about how to set up a network-based firewall to kind of add some basic protection at the edge of the network. Then we have another CentOS machine, which is going to be a website. We have an Ubuntu machine, we're calling it the workstation. In this case, it has an FTP and an SSH server on it. And then we have a Debian machine, which is going to be a DNS server that is going to point requests for the HTTP server over here. So those are the machines that we have here. I believe everybody should have, at least anybody who registered before today's date, which is December 19th, should have access to it. Again, unfortunately, this is only available to Illinois Tech students. And so if you don't have a Hawk email account, or an IAT email account, I won't be able to give you access to it. But at some point, we will release some sort of home virtual box setup for you. Some basic network commands, and I'll show you these when we're going through these. You can use ifconfig to figure out what your IP address is. This is a little bit deprecated, so some machines nowadays don't come with it anymore. I prefer to use IPA. So this will tell me the information that's associated with each of my interfaces on the machine. We can also use hostname-i to list the IP address. It's much shorter, and I'll show you kind of how that works. And then we can also list those ARP. So going back to the MAC address to IP address pairings, we could use the ARP address. And then routing allows us to show us where is it communicating. All right. So the first one we have is CentOS. And CentOS stores its network configuration in this folder here. So it goes in etc sysconfig network-scripts. And so let's go ahead and take a look at that. So if I go ahead and pull this up, I'm going to go ahead and jump right into my Cent router. Again, the login for that is root and root. So if I go ahead and scale this so it's easier to see, we have root and then root. So it's, again, the password is still root. So if I go ahead and use one of those commands that I had, if I look at IPA, so if I look at IPA, we see three things here. So we see localhost. So that's just if I want to communicate with myself. That's useful for a lot of reasons. So if you're just setting up a website that you just want to see locally for now, you may set it up on the local loopback address at 127.0.0.1. That's one thing that you could use for it. Let's say that you have a database, but you don't want to expose the database to the outside world. A lot of times, sometimes you'll use that on the loopback address as well, rather than hosting it externally. We have then two interfaces. We have ETH0 and ETH1. For the folks that are in the, let's see, give me one sec. For folks that are in the block B, you'll most likely see an additional, let's see, actually, no, that's in a minute. So I'll explain that in a minute. APA, yeah, no, actually it looks the same. I apologize for getting a little bit ahead of myself there. So we see two here. We see ETH0 and ETH1. So if I pull up my diagram again, if I go back, if I pull up my diagram, this refers to ETH0 is the IP address up here that's connected to the external network. And then ETH1 is connected to the internal network. So that's what's going on there. So that's what we're working with. And as I mentioned, if we hop over to etc sysconfig network-scripts, I'll do an ls-la. You feel free to do an ls, and we'll see a few things. Actually, I'm going to say ls. So we see a few different utilities that we can use. So for instance, we can turn off an interface, or we can turn on an interface. But we also see, as I mentioned, these two files. There are actually three files, because it also does it for the loopback address. So if we do ifcfg-eth0, that is for the external network interface, and ifcfg for Ethernet 1, which is our internal. So I'm going to go ahead and take a look at that. So let's go ahead and open up ETH0. So if we go ahead and read it, it notes that it's an Ethernet, which makes sense. In this case, we don't have a proxy that is available there. Boot proto, in this case, is DHCP. So what it's going to try to do is it's going to try and see if it can get an IP address assigned to it by some form of DHCP server. Default route, yes. IPv failure, no. If the DHCP server were to be handing out IPv6, it should, I believe, try and get that as well. We see the name is set to ETH0, and the UUID here is I believe, the MAC address. So this is the MAC address. So everybody will have a different one. So if this looks different to you, that's totally normal. My MAC address is going to be different than your MAC address, and that's perfectly normal. We see device Ethernet 0 and yes. So that's all we really need to know about that one. And the other one's going to be very similar. So if I go ahead and take a look at IFCFG ETH1, it's going to look exactly the same. It's trying to figure out what its IP address is based on DHCP, which makes sense. We want that to be kind of the natural fallback for our application. So give me one sec. Network scripts. I'm just getting ready for the small difference between the block A and block B. So there we go. So we've looked at least these two files here. There's a few other scripts that can be run here, so we can power down or power up our interfaces depending on what we want. There's just some samples there. So if we want to make a static configuration file, all we need to do is update a few things. So I'm still in. Actually, I'm gonna do this in Nano, just because I know that that's the easier one to work with. Head on in there. There's a few things that we need to change. So the first one is we don't want this to try and find a DHCP address. We're not using a DHCP server, so we don't need to do that. You can have, I wouldn't call it static, but you can have an assigned DHCP address. So on your DHCP server, you can note a given MAC address, and you could say this MAC address has this IP address, and it will always give it that IP address, rather than just getting it. It doesn't always. There's a refresh on it, so it won't always flush it every time that you turn off the machine. But after a certain period of time, I forget what I guess the lease is up in that sense. So there you go. So then the next thing that we need to change is we see that it's ETH1. You're welcome to, if you want to remove that MAC address, if you want to make it look similar. So I could do this. It will still work. I don't recommend it. So I'm actually not going to save those changes. I'm going to go back, but it will work. We're going to change this so that it does boot up. So when the machine starts up, we want to make sure that, hey, the interface is up and we have internet. We're going to add a line called IPADDR, so IP address. And in this case, we're going to set it to 192.168.0.1. So that's the IP address that we're going to use for our internal, our gateway. And then we'll add a prefix. In this case, it is a 24. And so this is the CIDR address. So we'll see this in a minute. We'll see it kind of show up. And this indicates what the CIDR or the subnet of the internal network is going to look like. If you have a mix match, so if I were to try and set up another machine in the network that, let's say it has a CIDR address of 20, the two machines aren't going to be able to communicate with each other because they'll think that they're on different networks. So that's just as an example. So I'll go ahead and write out and then exit. And if I cat out, I can show you that we did make those changes. So we see here, there we go. In order to apply those changes, we're going to use a utility called systemctl. We'll go over this more when we're doing some hardening stuff. But we'll be using the systemctl, and we're going to restart network. If I can spell it right. There we go. So we're going to restart network. Let's see. It looks like this might be erroring out, so I may have something incorrect here. So let's double check against the slide. On boot, yes. Okay. So it may be none instead of no. I think that's going to be the issue. Yeah, it's going to be none instead of no. So apologies. Oh, that would be it too. I forgot to change this to none. There we go. So let's try that again. There we go. So that returned immediately. If there's an issue that's going on here, typically hanging is not a good sign. And in this case, it meant that it was trying to find a DHCP address. And if I go back to IPA, we see that now this has populated with my IP address. So now this says the IP address that we wanted, 192.168.0. Now, if you're in block B, in this case, and it actually may have fixed itself, but sometimes when I was doing some troubleshooting, I noticed. Oops, I don't know. Am I there? Yeah, I'm in the right one. I noticed that sometimes it would call IFCFG EF1. It would call it like wired network connection. So it would be something like, and unfortunately, in this case, it's not showing it. So it's not being cooperative now. I don't know why it's not being cooperative now, but sometimes it would show up as wired internet Ethernet interface. Let me see if on another machine I can see it show up as that. Yeah, I don't know where it went. It was something that I was doing this morning. If somebody sees it like that, let me know. But all you need to do with that one is if it would be something like IFCFG wired, forget, it was like wired connection 1 or something like that. It was something wired. So you'd use the move command. So you'd move IFCFG wired blah 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 to IFCFG ETH1. And you can always double check, make sure. So if I do IPA, and this is the name that you're looking for, and what you would do is you would go in and you would modify the names. So the names would show up. Let's see, where is it? I'm in the wrong one now. There we go. So if I would do nano ifcfg eth1, and then you would have to make sure that you update these names. You'd update these names here. You'd update name, and then you'd update device with the proper naming. You can also, yeah, just be careful about that. Let me know if you see something like wired connection 1, and I'll help you out with making sure that it's up to one of it. Yeah. There's another utility that we can use. So we don't just have to use the IFCFG. We can use another cool tool called NMTUI. So with NMTUI, we can go ahead and we can edit a connection. In this case, it shows ETH0 and ETH1. So in this case, I can go to ETH1. I see the MAC address. And in your case, if it says wired connection 1, you just select wired connection 1. And you would go in and you would update this manual rather than saying this would initially say automatic. You would rather say this manual, and you would give the IP address. You give 192.168.0.1/24. In this case, we're not going to add a gateway right now because this is going to be our gateway, but that would be it. Then you go all the way down, you hit OK, and then you'd be done. So you'd hit X, and then you'd hit OK. You don't hit quit, hit OK. So that's how you'd set that up. And then you'll do an IPA, and you'll see, okay, great. My IP address has been updated. Now, one other thing that we want to do is we want to make sure that we're able to, from the inside, able to communicate with the outside. So we're going to use something called firewall CMD. And as the name implies, this is a firewall utility that we're going to be using later with our network, with our network stuff. So if I go ahead and take a look around, what we're going to end up doing is, and if I pull up the slide again, and I'm just going to pull this off to the side here and pull out the lovely image, my lovely network diagram. So if I go ahead and take a look here, again, we want to make sure that traffic flows through the router just directly out. So what we're going to do is we're going to use firewall CMD, and you can take a look at all the options. Like they use what's known as zones to kind of help give you some templates to get started. So firewall CMD. So firewall CMD -- list all zones. And of course, on this Linux machine, we can't scroll, so it gets a little bit tricky to read. But we see that these two have already been added to what's known as public, which is good. That's one thing that we can do. What we're going to shoot for is we want to take a look at two zones called list all. So in order to take a look at a specific zone, you'll say list - all zone equals external. And then we will also want to look at internal. So what we want to do is we want to go ahead and add. So we want to go to zone. We want to go to, we'll start with external. And then we'll add interface. Let me double check the exact term on that. I want to say it's add interface. Oops. Yeah, it's add interface equals ETH0. And I'm going to add a permanent. And it's going to kind of be weird. When you add permanent, it doesn't actually do it immediately. This just makes sure that like on restarts, that rule is still there. So we'll do this. Now you can add the zone to the IFCFG file. So if I go ahead and look in here, it automatically went in and edited the file for me. If I wanted to, I could add this manually. So if I do vim ifcfg eth1, and I go to the very end of the file, and I say zone equals internal. Let me just double check on the capitalization there. And I went ahead and did systemctl restart network. Just did that again. In this case, there we go. I do IPA, and then I do a fire, just make sure that it applied properly. So firewall CMD zone equals internal. list all, and we see that ETH1 is now there. So that's, we're happy about that. That worked properly, and it's ready to go. From that, the reason that this acts like a router is for this reason. Because of this masquerade, what this masquerade essentially does is it allows it to basically serve those requests. So it goes from the internal zone to the external zone. If you set the masquerade to yes, if you try to communicate with other machines, so if I kind of bring this example back out, essentially, if you want to communicate externally, the router will use its IP address to communicate on your behalf, essentially. So if I send a ping from internally, if I send a ping from this CentOS machine to this Kali machine, this Kali machine will see a ping from the router. So that's how that would function. So that's how we've got that set up, and that's it on the network side. We're done. We don't need to do anything else with that, and so that's all good. So we're done. We're done with that router. So next, let's go ahead and let's take a look at the internal one. So if I go ahead and I take a look at my website, so again, we don't have anything on here yet, but we will starting with Thursday. So if we go ahead and go root and root, and in this case, I'll use the empty UI. We'll go ahead and edit a interface. Goes ahead and fills up most stuff in for me. We're going to go ahead and change this to manual. We'll say show, and we'll go ahead and add an address. So in this case, 168.0.2, you want to make sure that you add your CIDR 24. And then in this case, we're going to add a gateway. So the gateway is essentially our way in which we can communicate with external networks. So we'll go ahead and do that. I can go ahead and add a DNS server. In this case, I'm going to add 8.8.8.8. I forget which one. Another one would be 1.1.1.1. These are, I believe, Google. And that'll get you access to any DNS server that you need, and it'll allow you to communicate or grab stuff from the web. So if I go ahead and clear IPA, it's gone ahead and made that change. We can verify that by saying ping 192.168.0.1. And as we can see, we're able to communicate. And then I'll say to kind of show, and here, I guess the test, I skipped a few testing on the set router. But let's see if we can ping google.com. And of course, that fails. So another way that we could also do this is we can go into a file called resolve.conf. Okay. Why did it skip? Give me one sec. Okay, that's really weird. Okay. Well, that's proper. So sometimes, I don't know why, but sometimes, and let me just double check real quick. Let's go back to the, we're going to go back real quick to the, we're going to go back. Let's just double check to make sure that we can ping Google. We can ping Google here. Let me just double check firewall CMD. Can I ping .2? I can ping .2, so those are working. And if all else fails, we can always just reboot the server and then see if that works. So I don't know why, but sometimes in networking, that just does the trick. So we'll go ahead and see if that adjusts it. So we'll go ahead and see that. And wait a second. Don't know why sometimes the local scaling gets weird. But let's go ahead and see that again. Go ahead and log in as root. Nope, it's still having problems. Let's see. Oops. Let's see. We'll come back to this one, and I'll make an addendum or I'll mention it on Thursday if I figure out why that's having problems reaching out to Google. Give me one sec. Yeah, I'm working with the same set. And that should work. Let me go ahead and I'll add a gateway real quick. Or not a gateway, a name server real quick. No, that's added, so that's all good. So sometimes this again, sometimes networking can be a little bit weird. Yeah, that works. And that works. Okay. I'll take a look at this in a minute. Maybe over the break, which is going to be about 5 or so minutes. I'll take a look at it and see if I can figure out what the issue is with that. Yeah, that's working. Oh, Rod's not on here. Yeah, I'll take a look at this in a few minutes. But we'll jump over to the Ubuntu one and then we'll take our break. But at least in terms of how Ubuntu does it, Ubuntu is going to use what's known as NetPlan. So we can find NetPlan in etc cd ett/NetPlan. So in this case, it starts with a default 00 installer, and we'll go ahead and use that one. So we'll do nano 00. In this case, it starts with, it calls this one ENS18. So let's just double check. In this case, it is still ENS18. So we'll go ahead and keep ENS18. And then in this case, it's blank. And in order to add our IP address, we just need to add the following line. So we need to add, see, and the spacing is really weird on these. So we have Ethernet, we have ENS18, we have addresses, we add the address that we want. Oops. We add 192. In this case, it's going to be .3 / and don't forget the CIDR. We'll add routes to default. In this case, it's going to be through the gateway. So the 192.168.0.1. And then we want to add name servers. And so this is going to be what's going to be giving us our access to the web. So addresses, and then in this case, 8.8.8.8, and then you add search. So we have ENS18, we add in addresses, we give the IP address for the static that we want, we add in our gateway here, and then we add in the DNS server. So in order to apply this, I do netplan apply. In this case, there's an issue. Of course, it's got a problem with tabbing, so give me a minute. So in this case, my I typically add 2. Let me just double check on the spacing here. There we go. So hopefully that doesn't have a problem. Oh, still problems. Oh, I forgot that I did not edit that one. There we go. There we go. So now that should, and then actually, I think this is spaced as well. Nope. You silly thing. Nope. Give me 1 sec. And of course, whenever we do anything live, it's good. There's always going to be a some sort of debugging that we've got to do. So let's go ahead and no, I'm just going to delete that line. I don't think we actually need that. I don't think we need search. Let's see. Come on. There we go. If I do IPA, we see that it is now the proper IP address. And let's see if you cannot find Google either. Okay, so there's an issue on the gateway side that I'll have to verify. But otherwise, it's able to ping everybody else in the network. So that's something that I'll double check during the break to make sure that that they're able to then communicate and download stuff. Let's see, let's do wget real quick. Yeah, it's having an issue resolving. So I'll double check on that on the Cent machine, and then we'll get that figured out. But we're gonna go ahead and take a break here. Depending on kind of how long questions take, maybe a little bit longer. So I'll catch you all at least on the online side when we get back. Of course. Alrighty, welcome back, everybody. So I did find a solution to the problem that I was having earlier. And turns out all I had to do was reboot the router. So you can do that with just a reboot now. Reboot now. It'll go ahead and turn itself off and then come back on live. Sometimes it's just the solution. I don't know why. I'm sure there's something internally that needed to get reconfigured there. But at least on my end, that's what ended up fixing it, and so that I was able to ping from the inside heading out. So we'll show that real quick. So root. So this is the router. So ping google.com. Perfect. That's as expected. So now I'm on the CentOS web machine. I'm going to go ahead and ping google.com. And we see here we get 64 bytes back from a 142 address. So we know that that's not anywhere internally. And then I'm going to go ahead and ping google.com on the Ubuntu machine. And we see here that same 142 address. So that's how we fixed it. Again, sometimes just rebooting it for some reason applies those changes. I'm not entirely sure why, but that's just how it is sometimes. And then the last machine that we've got, actually not quite the last machine, because we still actually technically still have the, and I'm sorry, I kind of missed a few of these slides here. But again, the Ubuntu, it's in etc not plan. So you can actually configure that YAML file right there. We can set a DHCP configuration with that. And then the static one looks like that. I don't know why it didn't work out right away, but it is what it is. And then finally, we have the Debian machine. And that one uses etc network interfaces. And so this one's actually the smallest of the three. So if I go ahead and jump on over, we'll go ahead and pop out and I'm actually going to start up my internal Kali machine because that's actually the last one. I didn't create any slides for that one, but that is going to be the last machine that we need to work with from that end. So go ahead and pop this guy open. It's again root and root. So that should be all happy. If I check my IPA, we are on ENS 18, and then I'm going to go into etc network interface, etc/network/interfaces. Of course, there's no Vim on this machine. I'm going to install that right away, but first we have to reach the internet. So here we go. We see the loopback address, and we're going to go ahead and add ENS 18. And let me pull up the slides on my end so that I can quickly cheat, I guess, here and double check the exact setup that I need. But it's going to be ENS 18, interface, iFace, ENS 18, iNet static. Then we can add the address of 192.168.0.4. Yes, 4/24. And then a gateway of, 192.168.0. So we can go ahead and save that. Again, that one's the shortest. And then this one is, again, referring back to systemctl, restart networking. Do a quick IPA, and we now have our new IP address. And the way that we're then going to set up our DNS resolving, we're going to go to resolve.conf, etc/resolve, resolv.conf. And actually, this one already has those two for us. So we actually don't even need to do anything. And I should be able to just ping google.com. So I'm able to ping google.com. If I want to install Vim, so let's say that you use Vim a lot more, like personally I do, Vim, apt install Vim. Go ahead and say yes to that, and it'll go ahead and download it, and you'll be good to go. So you'll be able to use that. Apparently, it's having some problems. It's not able to resolve. Well, I'm able to. Oh, hold on. That's weird. Oh. Oh, why did it? That's different. It literally just had an IP address. Let's restart. No, what the hell? Okay, that's really weird. Oh. Well, let's quickly take a look at this. So then, we're safe again. Let's remove this space here. I wonder if it's this. It shouldn't be this space, but I'm gonna do a reboot. Oh no, why? I see an IP address there. 192.3. I can reach him. Reach him. Okay, now it's working again. That's so weird. Okay, install. Okay, now it's working. Sometimes that's just how it is. I don't know why. Um, but there we go. Now it's able to download Vim. It's unpacking it, and now it's going to go ahead and install it. And then we're good to go. So now I can use Vim to my heart's content. So that's our Debian. And then we can jump on over to the Kali machine as well. Again, on block A students, it is Kali. On block B students, it is root and Tor. I believe root and Tor may actually, let me double check that. The root and Tor may work on the other machines too. Let me double check. I believe root and Tor is the default root. Oh, it is. Yes. Okay. It is the default username and password for root on Kali Linux machines. So that's just as a note there. Root and Tor. So Kali. So we'll jump on in here. And I personally, I just make it super simple. I go up in the top left here. And I guess this is just the difference between when you have a something that you're forced to do everything in the command line versus something that you're able to use a GUI with. I just go up here. I click on IPv4. In this one, it has an old one that I was using for something else. But in this case, my address is going to be 0.5. And then I'll give my new address. There we go. So go ahead and save. I believe I do have to do a reboot on this one. Let me check. Oh, yes, I do have to do a reboot. So in this case, I now have to run over and do a reboot. But it's much simpler, in my opinion, when you have a GUI. And it's the same with Windows too. Windows is a little bit, it's the same way. But yeah. So that's what we have on networking today. Hopefully that was interesting. If you've never, oh, and then the name server. So that's actually your DNS. So in this case, I was using resolve.conf a few times. It's already sent on Debian. We can set it in that plan, and then we could do it in CentOS. I believe CentOS, you could also do it in those IFCFG files as well. But we've done it. I've kind of shown you how to do this on a few different machines here. So how to use with CentOS. I've shown you how that you could use this with the IFCFG, NTM UI. We did it with Ubuntu with NetPlan, and then we did interfaces with Debian. So there's just a few different ways that you could do that. There may be more. I'm sure there's more, but at least those were there. And then we also set up a simple router configuration on the CentOS machine. So now we're able to just install. We're now able to contact the internet. So what we're going to do on Thursday is we're going to manually install. Well, not manually because we're going to be using the package managers. But we're going to go ahead and I'll show you from installation to then showing that it works for SSH, HTTP, and then DNS on a few of those machines. So that wraps it up for today. Let us know if you have any problems with the environment, if there's running into some of the problems that I was running into today. But hopefully you found this interesting and are ready to go for our ports and services on Thursday.